Alright, number 13, we want to find the derivative of tan squared x and secant squared x, and then what can be said about the difference f minus g. So I've written them down so we can see the chain rule in action, because we're going to do the chain rule derivative of the outside times the derivative of the inside. I'm going to refer to our course and our trig cheat sheet to get the derivatives of secant and tangent. Derivative sheet, this will be okay. Alright, and so we can see derivative of tangent is secant squared. Derivative of secant is going to be tan times secant. 1 over cosine is secant. Okay, so when we do the derivative, we're going to get derivative of the outside is 2 tan x. Derivative of the inside is going to be secant x squared. Alright, so that is the derivative of f. This is f prime of x. When we do derivative of g, we're going to get 2 times secant x, and then derivative of secant x was tan x secant x. Alright, when we simplify this, we can get secant times secant, which will give us secant squared, and so we can just say that this is equal to 2 secant x squared tan x, and basically this is the same thing. To pull the secant up front, secant squared x tan x. Alright, so we get the exact same derivatives, exact same functions when we do derivatives of both. Do they show the trig functions here? No, they do not. Alright, so we're just going to type it 2 sec secant x squared tan x. I'll move that out of the way. Alright, and then here we get the same thing. We get 2 secant x squared. The computer input has to put the square on the outside. It doesn't do it on the inside. Tan x. Alright. What can be said about the difference of f minus g? So, original f minus g is just tan squared minus secant squared, which, since these are squares, we could look at, let me go back, we could look at the trig identities and maybe find a little bit more insight. Tan secant squared is also equal to 1 minus tan squared. So if I were to kind of do a replacement, so if we say f minus g, that will be equal to tan squared minus secant squared. And then using the trig identities, we can see that I can just rewrite tan squared, or I can rewrite the secant squared. They're both the same. Secant squared is going to be tan squared plus 1. So let's just say tan so that replace secant squared, distribute the negative, the tangent will cancel out and leave us with a -1. And so since both of those derivatives are the same, we can say that they differ by a constant, which we can see that when we do the trig identity. And so it says, what can be said about the difference f minus g? Since functions with equal derivatives are always equal, it follows that f minus g is a constant, okay, which we can see that we get -1. Since functions with equal derivatives are always equal, I don't know if that reads correctly. Since functions with equal derivatives differ by a constant, it follows f minus g is a constant. There we go. Since functions with equal derivatives are always equal, functions with equal derivatives differ by a constant, it follows 0. Okay, so B